Namaste. Myself Javian Shivi Saxena, Faculty of Physiotherapy and Diagnostics. My, to- my today topic is centrifuge. Introduction. Centrifugation is a technique of separating substance which involves the application of centrifugal force. The, the particles are spread from a solution according to their size, shape, density, and viscosity of the medium and rotor speed. Principle of centrifugation. In a solution, particles whose density is higher than that of the solvent sink sediments, that means, and particles that are lighter than it floats to the top. The greater the difference in density, the faster they move. If there is no difference in density, the particles stay steady. To take advantage of even tiny differences in density to separate various particles in a solution, gravity can be replaced with the much more powerful centrifugal force provided by a centrifuge. A centrifuge is a piece of equipment that puts an object in rotation around a fixed axis, applying a potentially strong force perpendicular to the axis of spine. The centrifuge works using the sedimentation principle where the centripetal accretion causes denser substance and particles to move outward in the radial direction. At the same time, objects that are less dense are displaced and move the center. In a laboratory centrifuge that use sample tubes, the radial accretion cause denser particles to stay to the bottom of the tube, while low density substance rise to the top. Types of centrifuge. First, low speed centrifuge. Most laboratories have a standard low speed centrifuge used for routine sedimentation of heavy particles. The low speed centrifuge has a maximum speed of 4000 to 5000 rpm. These instruments usually operate at room temperature with no means of temperature control, and two types of rotor are used in it. First, fixed angle, second, swimming bucket. It is used for sedimentation of red blood cells until the particles are tightly packed into a petal and supernatant is separated by decantation. Next, high speed centrifuge. High speed centrifuges are used in more sophisticated biochemical applications. Higher speed and temperature control of the rotor chamber are essential. The high speed centrifuge has a maximum speed of 15,000 to 20,000 rpm. The operator of this instrument can carefully control speed and temperature, which are required for sensitive biological sample. Three types of rotator are available of high-speed centrifugation: first, fixed angle swimming and vertical rotor. Ultracentrifuges. It is the most sophisticated instrument. Ultracentrifuge has a maximum speed of 65,000 rpm. Intense heat is generated due to high speed, thus the spinning chamber must be refrigerated and kept at a high vacuum. It is used for both preparative work and analytical work. Types of centrifugation: first, differential plating, यानी differential centrifugations. It is the most common type of centrifugation employed. Tissue such as the liver is homogenized at 32 degree is in a sucrose solution that contain buffer. The humidifier is then placed in a centrifuge and spun at constant centrifugal force at a constant temperature. After some time, a sediments from at the bottom of a centrifuge called plate and an overlaying solution called supplementant. The overlaying solution is then placed in another centrifuge tube, which is then rotated at higher speeds in progressing step. Second, density gradient centrifugation. This type of centrifugation is mainly used to purify virus, ribosomes, membranes, etc. A sucrose density gradient is created by gently overlaying lower concentration of sucrose on higher concentration in centrifuge tube. The particle of interest are placed on top of the gradient and centrifuge in ultracentrifuges. The particles travel through the gradient until they reach a point at which their density matches the density of surrounding sucrose. The fraction is removed and analyzed. Third, rate zonal density gradient centrifugation. Zonal centrifugation is also known as band or gradient centrifugation. It relies on the concept of sedimentation coefficient. That means movement of sediment through the liquid medium. And next, in this technique, a density gradient is created in a test tube with sucrose and high density at the bottom. The sample of protein is placed on the top of the gradient and then centrifuged. With centrifugation, faster sedimenting particle in sample move ahead of shore ones. For example, sample separated as zone in the gradient. The protein sediment according to their sedimentation coefficient and the frictions are collected by creating a hole at the bottom of the tube. Next, symphonic centrifugation. The sample is loaded into the tube with the gradient forming solution. On top or below, preformed gradient or mixed in with self forming gradient. The solution of the biological sample and salt is uniformly distributed in a centrifuge tube that rotated in a ultracentrifuge. Under the influence of centrifugal force, the used salt redistribute to form a density gradient from top to bottom. Particles move to point where their buoyant density equals that part of gradient and form bands. This is to say the sample molecules move to the region where their density equals to density of gradient. It is a true equilibrium procedure since depends on wavelength density, not velocities. Applications of centrifugation. First, to separate two miscible substance to analyze the hydrodynamic properties of macromolecules, purification of mammalian cells, fraction of cellular organelles, fraction of members vesicles, separating chalk powder from water, removing fat from milk to produce skimmed milk, separating particles from an airflow using cyclonic separation, the clarification and stabilization of wine, separation of urine compounds and blood compounds in forensic and research laboratories, adds in the separation of protein using purification techniques such as a salting out, example ammonium sulfate precipitation. And thank you.